Good morning to all. So my topic is the two important cross-linking reaction of polymers. That is, one is vulcanization and other one is Cure reaction. We know that cross-linking means it is the bridging formed between linear polymer chains leading to a three-dimensional network structure. Okay. So first we can go through vulcanization. It's a widely used technique in rubber technology to effect cross-linking. That is, it is mainly used in rubber technology to provide cross-linking. And it was discovered by Goodyear in 1839, and he used sulfur to cross-link polyisoprene molecule in natural rubber. Next, the definition of vulcanization. It can be said that it is the process by which the physical properties of the rubber can be improved by heating it with vulcanizing agents such as sulfur powder, peroxide, and the peroxide may be benzoyl peroxide, zinc peroxide, etc. That is, it is the process through which we get a rubber with the desired properties for industrial purpose by heating it with the vulcanizing agents such as sulfur peroxide, etc. Also, it is the process of increasing elasticity while decreasing the plasticity of the material. That is, on vulcanization, the material become more elastic while the plasticity of the material is decreased. Next, cross-linking using sulfur. We can see that here two polyisoprene molecule is taken and it is cross-linked using sulfur S8. Then on cross-linking we get a cyclic compound like this. Here the CH double bond says that double bond is gone and sulfur is cross-linked to give such a structure. And so the vulcanization can be done without affecting that double bond by elimination of H2S. Here we can see the double bond is retained there and H2S is eliminated. Here SX is written because it is not necessary that it is always S8. It may be S4, S2. Okay. Next, cross-linking can be done using S2Cl2. The two polyisoprene molecule are cross-linked using S2Cl2. Here double bond is gone and sulfur is cross-linked to give such a structure, and the liberated sulfur can provide further cross-linking. Next, cross-linking can be done using thioacids, mercaptans, mercapto acids, etc. Here thioacid is used instead of COOH, COSH. Okay, so two polyisoprene molecules is cross-linked using thioacid, and then we will get a structure like this. The double bond is gone and the thioacid is cross-linked there, so we will get such a structure. And then elastomeric cross-linking without employing sulfur. That is, cross-linking can be done without using sulfur. Here zinc oxide is cross-linked. Zinc oxide is used for cross-linking. Here instead of polyisoprene, polychloroprene, that is synthetic rubber is used, and the oxygen is cross-linked there. Here double bond is retained there, and zinc chloride ZnCl2 is eliminated. So elastomeric cross-linking without employing sulfur. Next, as a comparison between natural rubber and vulcanized rubber. So here there is a mistake in the first column. Instead of natural rubber, it is written as vulcanized rubber. So the natural rubber, which is soft, on vulcanization it become hard, and the natural rubber, which is less elastic, it become more elastic on vulcanization. We said that on vulcanization the elasticity of the material is increased while plasticity of the material is decreased, and the vulcanized rubber, which has no heat resistance, but on vulcanization it become more resistant to heat, and the natural rubber which has a low melting point, and on vulcanization it will get a high melting point, and the natural rubber which is easily oxidized, and on vulcanization it is more resistant to oxidation. Next, that's all about vulcanization. That's vulcanization is mainly used in rubber technology to provide cross-linking, and it was discovered by Goodyear, and he used sulfur to cross-link, and as a definition, it is the process through which the physical properties or mechanical properties of the rubber can be improved by vulcanizing, by heating it with vulcanizing agents such as sulfur or peroxide, and during vulcanization the material become more elastic while the plasticity of the material is decreased. Then we go through some reactions, cross-linking using sulfur and all. Then as a comparison, that's all about vulcanization. And next we can go through the other reaction, that is cure reaction. So curing is a chemical process employed in polymer chemistry that produces the toughening or hardening of a polymer material by cross-linking of polymer chains. That is, cure reaction is another reaction which provide cross-linking in polymer chemistry. So in cure reaction there is an uncross-linked polymer which contain either a reactive functional group or a double bond in their molecules. They are usually they do not have a very high molecular weight, but they are in the form of liquid resins. So such polymers are called prepolymers. That is, prepolymers are the liquid polymers possessing reactive functional groups or double bonds. Next, curative or curing agent. The low molecular weight or the polymeric material used to bring about the cure reaction. So this curative will react with the prepolymer to bring the cure reaction, and it will result in a cross-linked solid polymeric mass. Okay, then the condition for cross-linking, that is, for cross-linking to take place, both the prepolymer and curative should not have a minimum functionality of 2, but one or both of them should have some trifunctional molecule also. That is, the necessary condition for cross-linking to occur is that either the prepolymer or the curative or both of them should have some trifunctional molecule, because the trifunctional molecules provide sites where linear molecules can be connected through interchain links that leading to cross-linking. So trifunctional molecule provide the site for cross-linking. If they do not possess any trifunctional molecule, the cross-linking does not take place, and instead of that cross-linking there occurs a linear coupling between this prepolymer and curative. Okay, then the amount or degree of cross-linking depends upon the ratio of bifunctional to the trifunctional molecule present in the system. Next we can go through some examples. First, curing of an unsaturated polyester resin using styrene and a free radical initiator. So here the prepolymer structure is an unsaturated polyester resin. Prepolymer must contain either a reactive functional group or a double bond. Here it is containing a double bond. So and the curative structure is a low molecular weight substance or a polymeric material. Here it is styrene. So on the cure reaction will take place between this prepolymer and curative in presence of a free radical initiator. We get a structure like this. Okay, that is, the polyester with a pendant styrene groups are obtained, and this will continue in chain like reaction to give a cured network structure like this. Okay, then we get a cured network structure like this. Next, another example is curing of thiol terminated polysulfide resin with lead dioxide. Here the prepolymer structure is the polysulfide resin, and the curative is PbO2, lead dioxide. So on Q reaction with this polysulfide and lead dioxide will lead to a structure like this, and PbO and H2O are eliminated. And a queued network structure will be like this. Here we can see a linear polysulfide resin having a cross-linked polysulfide, which is due to the reaction with the lead dioxide. Okay, so that's all about Q reaction. That is, it's another reaction which provide cross-linking in polymer chemistry, and here there is a pre-polymer, that is a liquid resin that may contain either a reactive functional group or a double bond. Then curative or curing agent, it is low molecular weight substance or a polymeric material. It will bring the Q reaction. It will react with the pre-polymer to bring the Q reaction and will result in a cross-linked solid polymeric mass. Then the condition for cross-linking to occur is that either the pre-polymer or the curative or both of them should contain a trifunctional molecule. If they do not possess a trifunctional molecule, instead of cross-linking, there occurs the linear coupling between the pre-polymer and curative. So that's about Q reaction. Then we go through two examples. There are many more examples in Gavarikar textbook. I include only two. So that's all about Q reaction. Thank you.